Dam. The dams are used to store the water to avoid floods and disasters caused due to them. As the height of the water stored in the dam increases, the gravitational potential energy of the water increases simultaneously. When the dam water is released, this stored energy is converted into the kinetic energy of the water. The hydrostatic pressure due to the molecules of water on each other increases with the depth as the mass overlaying increases with the depth, and therefore the pressure exerting on the unit volume of the water also increases. Pipe. The flow of the water through pipes is because of the pressure difference between the two ends of the pipe that makes it possible for the flow of water. The pressure inside the pipe is increased as the diameter of the pipe is less and the volume of water is more. Container filling with tap water. As the container kept under tap gets filled with water, the hydrostatic pressure exerted on each other by the molecules of water and on the surface of the container increases with every rise in the volume of the water in the container. The hydrostatic pressure depends upon the height of the layer of the water in the container. Even if the shape and size of the container and the volume of the water stored in the container differ, the hydrostatic pressure will be equal if the level of the water lies at the same height in all the containers. Sugar mixed in water. If you add sugar cubes to the glass of water, a hydrostatic pressure will be exerted on every cube of water from all sides. That will take time for the sugar to mix well in the water. Erosion. You must have noticed that collapsing of the surrounding mass of land near the water bodies into the water. The hydrostatic pressure exerting on the surrounding area in close vicinity of the volume of water which has great storage of potential energy with it, the soil particle is not able to withstand with the hydrostatic pressure for longer once the landmass becomes saturated with the water molecules on absorption. Deposition. Depending upon the density of the particles and objects dropped in the sea or river water, the objects settle on the seafloor or on the abyssal plane. These objects undergo hydrostatic pressure. This hydrostatic pressure varies depending upon at what depth of the sea the object is present. The lighter objects are carried further in the abyssal plane. Buoy. It is used to detect the route through the river or is attached to the fishnet to identify and keep the net held at the surface of the water. This is possible because of the hydrostatic pressure exerted on the buoy by the water molecules present on the surface of the water and also because of the buoyant force exerting on the buoy. Divers underwater. Divers underneath the water at depths experiences pressure thrice the atmospheric pressure. This is because the seawater is full of salts and mineral, and in addition the hydrostatic pressure due to different molecules is exerted from all the sides of the body of the diver. This hydrostatic pressure increases as the diver dives deeper and deeper into the sea. The penetration of light also decreases as the hydrostatic pressure increases at every level of water. Hydraulic separation method. It is a method used to separate the minerals and elements from the ore. The ore is mixed with the water, the denser particles settle down while the gangs remain suspended above the surface of the water. These gang particles are excreted out from the ore. Rivers and oceans. Rivers and oceans are storehouses of gravitational potential energy. As the height of the water level increases, we can say that the gravitational potential energy also increases. The hydrostatic pressure increases with the depths. The turbidity of the water is due to the tidal force exerted due to the gravitational pull of the moon. Precipitation. The precipitation occurs when the two substances get mixed well and settle down to form a hard substance. If the compound is mixed in the water, the particles of the matter will remain suspended in the water due to the hydrostatic pressure exerted on the particles. The denser matter first settles down and subsequently forms the layers of the matter depending upon the size of the grain of matter and the density. Osmosis. Osmosis occurs when the water molecules penetrate through the semi-permeable membrane from high concentration to the low concentrated solution. The hydrostatic pressure is more in a solution that is highly concentrated and thus travels in a low concentrated solution following the law of equilibrium of state. Water tankers. The tankers are used to store the water. The water is in a static state. The hydrostatic pressure of the water inside a tank depends upon the height of the volume of water in a tank. The hydrostatic pressure decreases as the volume of the water in a tank reduces. Boat and cruises. The buoyant force is very important to keep the object floating over water, which results due to the difference in the pressure on the body of the object. The hydrostatic pressure is exerted on the surface of the boat or cruises floating on the water. If the boat is not kept tightly attached near the shoreside, then it will sway away with the hydrostatic pressure exerting on it. Watering cans. The hydrostatic pressure of the water in a can present at a certain height doesn't depend upon the height at which the watering can is kept. The hydrostatic pressure inside a can for a particular level of water in a can will be the same even if you kept it on the table or on the ground. Perhaps the level of the water does not change. Frequently asked questions. How does the hydrostatic pressure measure? It is measured using the formula P equals pGh. The hydrostatic pressure increases as the height of the volume of the water level increases, and also depends upon the density of the water and gravitational potential energy. What is the hydrostatic pressure of the water kept in a tanker of a height of 1.5 meters and is completely full? Given, H equals 1.5 m equals 1000 kilograms per cubic meter. G equals 9.8 ms2. We have P equals pGh is equal to 1000 times 9.8 times 1.5 equals 14,700 pascals. Hence, the hydrostatic pressure of the water in a tanker is 14,700 pascals. What is the hydrostatic pressure in the seawater kept in a glass at a level of 10 centimeters at a temperature of 50 C? Given, H equals 10 cm equals 0.1 m. The density of seawater at 50 C is P equals 1028 kg/m3. We have P equals pGh is equal to 1028 times 9.8 times 0.1 equals 1007.4 pascals. Hence, the hydrostatic pressure on the seawater inside the glass is 1007.4 pascals. Please visit our website lambdageeks.com for more articles on technology, engineering, mathematics, and various other domains. Scientific calculator and many more other tools.